Slide lecture. Complex additives. For students of the educational program Production of Building Materials, Products and Structures. Topic: Methods of preparation and application of effective modifiers. Lecturer, Associate Professor, Ph.D. Sarova R.F. Lecture plan. 1. Complex additive groups. 2. Complex additives of group I. 3. Complex additives of group I. 4. Complex additives of group IE. 5. Complex additives of group IV. 6. Complex additives of group V. 7. Complex additives multipurpose exposure. 8. New types of complex additives. The purpose of lecture. Study the complex additives and complex additive groups. Consider new types of complex additives. Experience with the use of additives in concrete shows that in many practically important cases, complex additives are the most promising. The main advantages of multi-component additives in the general case are expressed in the fact that monoadditives often, along with the positive ones, also have a negative effect on the properties of concrete and mortars, which reduces their effectiveness. For example, the use of medium and low plasticizing additives can significantly increase the mobility of concrete and mortar mixtures. However, at the same time, they can cause an unacceptable decrease in the strength of concrete or mortar. Using various monoadditives, it is possible to significantly lower the freezing temperature of water in concrete mixtures, but some of them accelerate the setting of cement paste and cause corrosion of steel. Therefore, in order to increase the efficiency of the use of single-component additives for various purposes, It is necessary to introduce such complexes into the concrete composition that could localize the negative effect of monoadditives or enhance the desired effect, and if necessary, give concrete or mortar new properties. Complex additive groups. Complex additives, depending on the technological effect and the effect on the most important properties of hardened concrete and mortar, are conditionally divided into 5 groups. 1. Mixtures PAV. 2. Mixtures PAV and electrolytes. 3. Electrolyte mixtures. 4. Complex additives based on superplasticizers. 5. Multi-component additives of multifunctional action. Complex additives of Group 1. Complex additives of Group I combine substances of hydrophilic and hydrophobic nature. As noted earlier, PAV show a different degree of effectiveness when using cements with different mineralogical composition. For example, up additives are more effective in concrete on medium and high aluminate cement, and hydrophobic additives, GEC-10, GEC-11, SOLV, CONT and others, are more effective when using cements with a high content of silicate phase. The initial mobility of mixtures with complex additives is maintained for 2-3 hours, which is important when transporting mixtures over long distances and when concreting in a dry, hot climate. The corrosion resistance of concrete increases, its frost resistance increases by 2-3 grades and water resistance by 1-2 grades. However, it should be noted that additives of Group I slow down the setting and hardening of concrete. Therefore, it is necessary to make adjustments to the concrete technology. Complex additives of Group 2. Promising is the use of complex additives of group I, consisting of plasticizing substances and additives electrolytes that accelerate the setting of concrete. This allows you to simultaneously save cement and increase the turnover of molds and all process equipment, regardless of production technology. In addition, while maintaining the mobility of the concrete mixture, a 15% reduction in water consumption is achieved, which increases the strength of concrete by 25%, and also increases the frost resistance and water resistance of concrete by 1.5 grades. Provided that equal strength concrete is obtained, it is possible to reduce cement consumption by 15%. Complex additives of group 3. In complex additives of group IE, the combination of electrolytes eliminates the negative effect of some monoadditives and maximizes the effect. In cases where it is required to obtain ultra-fast setting of the mixture without a noticeable decrease in the subsequent properties of concrete, a mixture of sodium aluminate and potash additives is used. A special effect is manifested in the non-additive effect of the complex additive on the earliest stage of structure formation of the concrete mixture. This allows you to reduce the setting time to 10-20s. Regardless of the mineralogical composition of the cement, and when water is heated to 40 C, almost instant setting of the concrete mix is ensured, which is very important for sprayed concrete, shotcrete. Complex additives of group IE are mainly used for concreting at landfills and construction sites in the cold season at low temperatures. Complex additives of group 4. Complex additives of group IV, modifiers based on superplasticizers, are most effective and expedient in concrete technology. Complexes, including superplasticizer and hardening accelerator, can reduce the duration of heat treatment of concrete by 20–40%, and in some cases, abandon it. The structures intended for reinforced concrete structures with high frost resistance and water tightness include air entraining and water repellent components. For highly mobile and cast concrete mixtures, it is advisable to add water holding, stabilizing components, as well as setting retarders to the superplasticizer. In the manufacture of prestressed concrete products, complexes with superplasticizers should include effective steel corrosion inhibitors and additives with a hydrophobic effect. Complex additives of Group 5. Complex additives of Group V are complex multi-component complexes designed to give concrete special properties. This group includes bitumen emulsion and emulsion suspensions, which are prepared on the basis of bitumen, alpha and water. For the emulsion suspension, kaolin suspension is also added. These additives, being seals and hydrophobic plasticizing components, are used to increase the impermeability and durability of reinforced concrete structures. To obtain non-shrinking and expanding concretes, it is advisable to use a complex including aluminum powder, lignosulfonate and sodium sulfate, Packelstchat. The components of the complex product, entering into chemical interaction with calcium hydroxide, are able to form calcium hydrosulfonates and have an expanding effect on the hardening system of concrete. Complex additives multipurpose exposure. Complex multipurpose additives have a multifunctional effect, that is, the ability to affect several characteristics of concrete at once, often not related to each other, and in some cases to give concrete new properties. Complex multipurpose additives have a multifunctional effect, that is, the ability to affect several characteristics of concrete at once, often not related to each other, and in some cases to give concrete new properties. New types of complex additives. Relamics. A complex product based on sodium salts of polymethylene naphthalene sulfonic acids and accelerators for gaining strength. Additive in the form of a water-soluble powder of light brown color or an aqueous solution of dark brown color, having a concentration of not less than 32%. Allows you to completely abandon the heat treatment of concrete. Recommended dosage 0.6. 1% of the Massachusetts of cement. Linamix. A complex product based on sodium salts of polymethylene naphthalene sulfonic acids and setting retarders based on lignosulfonates. Additive in the form of a water-soluble brown powder or an aqueous solution of dark brown color, having a concentration of at least 32%, increases the survivability of the mixture up to 2.5 hours. Recommended dosage 0.3. 0.4% of the Massachusetts of cement. Defoamix. A complex product based on sodium salts of polymethylene naphthalene sulfonic acids and defoamers, air suppressing component. Additive in the form of a water-soluble brown powder or an aqueous dark brown solution having a concentration of at least 32%. Provides a reduction in air entrainment into the concrete mixture to 0.8. 1% dosage 0.4. 0.8% of the Massachusetts of cement. SS-15. A complex product based on sodium salts of polymethylene, naphthalene, sulfonic acids, and an antifrosty component based on sodium formate. Additive in the form of a water-soluble brown powder or an aqueous dark brown solution having a concentration of at least 32%. The additive does not contain caustic substances. The content of chloride ions is not more than 0.1%. Provides a standard set of strength at temperatures up to -15. Dosage 1, 1.5 and 2.5% corresponds to the ambient temperature. -5°C, -10°C and -15°C. PFMN, complex additive based on plasticizing, air entraining and hydrophobizing components. Additive in the form of a water-soluble brown powder or an aqueous dark brown solution having a concentration of at least 32%. Allows you to get cast mixtures and refuse additional energy costs for sealing. Dosage 0.3 0.7% of the Massachusetts of cement. Hexalate. A complex additive based on plasticizing action components and setting accelerators. Provides a set of concrete strength at the daily age -80% of the design. The powder additive is introduced into the mixture of the dry components of the mixture. Dosage 7.5% of the Massachusetts of cement. Biotechan, a multifunctional additive based on plasticizers, hardening accelerators and other components that increase the frost resistance and water resistance of concrete and mortar. It is used with no additional Portland cement. The powder additive is introduced into the mixture of the dry components of the mixture. Recommended dosage 1.5 2.5% of the Massachusetts of cement. Rheomix 405. A mixture of a plasticizer based on lignosulfonates and accelerators based on chlorides can be used as an anti-frost additive, providing hardening of concrete at temperatures up to -10. Dark brown liquid with a density of 1.34 k/L. Chloride content -0.75% by weight of cement. Not recommended for use with high alumina cements. Dosage: 1.7 L per 100 K of cement at an ambient temperature above -4 C and 3.4 L at a temperature from -4 C to -7 C. Universal P-2. A complex additive based on highly plasticizing components, hardening accelerators, an air entraining agent and a steel corrosion inhibitor. The product is in the form of a brown powder. Compatible with foaming agents Penestrum, PG-2000. Allows you to abandon the heat treatment of concrete. Helps increase the frost resistance and water resistance of concrete by 1-2 grades. Recommended dosage: 0.5. 0.6% of the Massachusetts of cement. Monolith -2. Modified alcohol plasticizer based on sodium, with anti-frost effect. The additive does not contain chlorine ions, does not cause corrosion of valves. The product is in the form of a powder or concentrated solution. Recommended dosage as a plasticizer: 0.6. 0.8% of the Massachusetts of cement, as an anti-frosty additive. 1.5% at temperatures up to -5 C. 2. 3.5% at temperatures from -6 C to -15 C. Lignopan B. A complex based on plasticizing components and hardening accelerators for concrete and mortars. Product based on lignosulfonates and inorganic salts, does not contain chlorides, in the form of powder or solution of 30% concentration. Dosage 0.6. 1.5% of the Massachusetts of cement. Control questions. 1. What are the complex additives? 2. What exist the complex additives groups? 3. What new types of complex additives do you know?